All right, our next speaker at UNSOMNIA is Matt England. He's the ARC Laureate Fellow and Scientia Professor. Matt England is an expert on the physics of the oceans and their role in climate variability and climate change. He's the academic lead of the Climate Change Grand Challenge. And speaking about our warming oceans and the planet's future, please welcome Matt England.
I feel I need a guitar, a backing band. Thanks for the welcome. Thank you, everybody, for coming today. I want to start off with a little bit of a thought experiment. I want to think about an intergalactic mission of astrophysicists approaching our planet. And they're approaching it just by chance with the Pacific in view. And surely the first thing they would marvel at is the almost total coverage of our planet with seawater, with oceans. They could even mistake for a moment that they're approaching just yet another planet covered by water, another aqua planet. If they got around to landing somewhere here and if we happen to still be around, they might even ask us, why did you call the planet Earth and not ocean? Such is the dominance of ocean over our planet. If there's a evolutionary biologist on board, surely she would have read all of Rob's papers and she'd work out pretty quickly that life on Earth, on the planet, sprung from the oceans. And they'd know about the laws of thermodynamics. They would have been good physicists to get this intergalactic voyage going. So having nailed the laws of physics and the laws of thermodynamics, they would know that the oceans that cover our planet have a profound influence on our climate system. So that's the thought experiment. That's where we start. I want to come back to here and now. So much for the aliens and the space travel and so on. I want to talk about what we know about the oceans today. And we know a lot, actually. We know a lot about how the oceans play a profound role in moderating our climate system. One prominent example is that the oceans take a lot of heat from the tropics to high latitudes. So as you know, with a spherical Earth, we've nailed that. Flat Earthers are no longer with us, really. With a spherical Earth, the lion's share of solar radiation reaching the planet hits the tropics. That warms that part of the Earth. And the ocean does its best to move this warmth poleward. It does so much like an oil slick wants to spread across the ocean because warm water is very buoyant. We can't really stop the oceans doing this. They just do it for us. And the amount of energy transferred poleward in this process is 100-fold our global electricity consumption. So the heat being transported from the tropics to high latitudes profoundly moderates the extremes of climate we see. Without an ocean on our planet, the poles would be 30 degrees colder and the tropics 30 degrees warmer. So you can imagine there'd be no human civilization around the tropical belt. It would be way too hard for our bodies to acclimatize or to resist that. There are other ways that the oceans change our climate system and moderate the extremes of heat we experience. Our seasons, for example, are profoundly milder by virtue of having an ocean on our planet. Sydney, for example, would see every day of summer well over 40 degrees Celsius without an ocean on our planet. A heat wave would be 60 degrees Celsius. Bushfire season would be crazily difficult. Of course, we would have adapted. We would have different species here handling that, but we wouldn't like it in our present form. And then winter comes along and the temperatures would be sub-freezing every day of winter. And this seasonal cycle of heat it would be so much more extreme because what the oceans do for us is they have this amazing capacity to draw down heat during summer, leaving our summer temperatures relatively mild. They hold it during autumn and then release this heat back to the atmosphere during winter. And that free heating and cooling service completely moderates the climate system that we have around the world's coastlines. You only have to go inland a little bit. The next summer heat wave we have, if you're sitting off Coogee Beach, the temperature you're experiencing there will be 10 or more degrees Celsius, more mild than what you would see just across at Parramatta. So the oceans are incredibly benevolent to us in terms of this moderation of heat extremes. One really nice example that I like to talk about for any Europeans here is the North Atlantic overturning circulation. That circulation alone halves the electricity bill for 500 million people living in Europe. It's a massive heat overturning engine. It's linked to past glacial and interglacial cycles. If we slow it down and European climate freezes, if we accelerate that overturning, Europe enjoys the balmy climate it has today. So the oceans aren't always completely benevolent and benign. We've seen 3 extreme storm surge events destroy infrastructure along the coastline of New South Wales. So we know they're not always benign, but in terms of heat uptake and moderating the extremes of heat we experience on this planet, they're incredibly kind to us. And if you think about it, they provide life on Earth, they provide food for humans and other species. They're a provider of the moisture that goes into the atmosphere that feeds our rivers, and those rivers then are used by humans to grow food and for the very fresh water we drink. So the oceans are absolutely fundamental to life on Earth. However, we're now undertaking a new experiment altogether, a geophysical experiment that is unprecedented in human history. It's unplanned. Nobody sat down and said, let's do this. Let's raise greenhouse gases by a lot. It's not funded by any research organization that has any credibility. It's got no foreseeable end. So it's an uncontrolled experiment, no foreseeable end, unplanned. It's kind of what scientists don't like doing. And what we're doing in this experiment is pushing our greenhouse gases up to at least double pre-industrial levels. So go back only 100 years, the start of the 20th century, our carbon dioxide levels then that supported a relatively benign, stable climate, we're going to have those doubled within 30 years. That's the trajectory we're on. It doesn't look like changing. The last time we had carbon dioxide levels that high is well before human civilization. You have to go back 2 to 3 million years to an era when carbon dioxide levels were about 600 parts per million. And back then, Earth's climate was only 2 degrees Celsius warmer than today. It doesn't sound like a very bad thing when you think about a cold winter's day, or even a hot summer's day. 2 degrees doesn't sound too bad. But sea level was 25 meters higher than today. And the reason it was so much higher is that ice sheets melt in response to that temperature threshold. And that's why we're worried about the planet's future. So I spoke before about the oceans being benevolent and kind to us. In climate change, they are as well. This is my only graph. And as a scientist, I wanted to turn up with 27 graphs to show you. This is my only graph or chart, and it's almost like a Where's Wally kind of image. Where's the heat gone to? We know that we've increased greenhouse gases by a certain amount. We can quantify the exact amount of energy that's put into the system. If we go looking for where that energy resides, it's really obvious where to find it. It's sitting, 93% is sitting in the oceans. A little bit in the atmosphere, mainly by virtue of the atmosphere sitting on top of the ocean and receiving that warmth back. Some has gone into ice melt and so on. So this crazily unplanned experiment is kind of being buffered. So I said it was uncontrolled, but actually it's kind of being controlled and buffered by the oceans. They're taking up heat in vast quantities. This is kind of good because the energy trapping of greenhouse gases at the moment is equivalent to the same energy as 4 Hiroshima bombs every second of every day. That's how much energy we're trapping in the system with these extra greenhouse gases. So it's good that the oceans are taking up this energy and this heat for us. There's going to be some payback, though. I'll talk about that in a minute. They're also doing a massive apparently free, carbon uptake service for us. So you will have heard of ocean acidification. The reason the oceans are acidifying as time goes on is that the amount of carbon in our atmosphere is increasing, and all the while the ocean is acting like a sponge to absorb that carbon for us. As soon as you have higher concentrations of greenhouse gases in the atmosphere, the ocean will readily absorb that extra carbon dioxide. It's a bit like the opposite of a soda can opening, the carbon dioxide fluxes out. The disequilibrium favors carbon going into the ocean. Of our 10 billion tons every year of emissions, over a quarter are going into the ocean free of charge because the oceans just do that for us. So unfortunately, there's payback. The bad news story is that oceans acidify due to that carbon uptake. So we don't want them to uptake the carbon. By doing that uptake, they're acidifying, they're threatening ecosystems worldwide, and that alone is enough to address our carbon emissions. Even if they didn't warm the planet, ocean acidification alone is enough to address this problem. Coral reefs are under threat. Marine ecosystems from the very lowest part of the food chain right up to the top will be compromised with this ocean acidification. And I want to get back to ocean heat absorption. The absorption of heat is not without consequence either. Everybody is familiar with the expansion of materials when they warm, whether it's a gas, liquid or solid. The oceans will also expand due to this massive uptake of heat. But there's more problems with the ocean heat uptake. Iconic modes of variability like the El Niño Southern Oscillation that drive drought cycles over Australia are becoming more extreme as the planet warms, and they're expected to keep on getting more extreme. We're expecting to see stronger El Niños and more frequent El Niños in a warming world. Tropical cyclones only come along during summer. They need summer warmth to intensify. We don't expect to see more of them in the future, but when they do come along, we're very much expecting them to be more intense. And we've already seen this happen with more Category 4 and 5 cyclones in the recent past. But perhaps the biggest problem that ocean warming will throw back at us in the future is ice melt. And that's that 25-metre level I had for you previously. This is the bit of the climate system that is the slowest to respond, but also the most devastating. And it's a very hard part of the system to turn around. Ice sheets sit over our polar caps. More than 60 metres of sea level sits over Antarctica, locked up in frozen ice. A lot of that we think is stable, but there's a big chunk of it in the West Antarctic sector that is grounded on land that extends out over the ocean, and it's in direct contact with seawater. Ocean temperatures there are warming very rapidly. Go home tonight and put a cube of ice in a glass of water that's room temperature and in air at room temperature, and one will disappear very quickly, the other will sit there for a lot longer. And it's the one in the glass of water that goes quickly. The heat capacity of water, the very stuff that we enjoy as a moderator of our seasonal cycles, is the property of seawater that will melt the ice rapidly. It can store heat very effectively, it can move it somewhere else, and it can release that heat to the atmosphere or melt ice. So, ice sheets are melting. The sort of level we're expecting to see at the end of this century is about 1 metre. We might be lucky, it might come in under 1 metre. It could go over 1 metre. The higher end is harder to pin down because ice sheets have a destabilisation process that can see more rapid collapse. So we can grow them quite slowly and steadily. We can actually collapse them relatively rapidly. So the system's non-linear and it has us all concerned. Darlene gave a wonderful account of loss of habitat in the Torres Strait area. This is what we're seeing worldwide in low-lying coral atolls. We're seeing heavily populated delta regions where huge populations are living near the ocean that feeds them, becoming under threat with rising sea levels. So in terms of the future, this 1 metre of sea level rise, it is going to displace large numbers of people. Just in the Asian megadeltas alone, there are tens of millions of people who would be displaced at 0.5 to 1 metre of sea level rise. Island nations will be lost. Global security will be stretched, coupled with the inability to grow food as easily today, as easily in the future as we can today. The scarcity of fresh water for drinking, the pressure on populations and ecosystems will be profound. But right now, we're kind of just chilling out, right? We're kind of enjoying slightly balmier ocean temperatures. Planetary temperatures have kind of made for mild winters. We kind of forget about climate change every winter and kind of go, this is nice, it's a warmer winter. And all the while, the ocean's kind of giving this free heat uptake service, but with a massive debt down the track. So in a way, it's free at the moment for heat uptake and carbon uptake, but the cost down the track is huge. So in a way, we're handing our kids massive credit card debts, huge. And it's unthinkably immoral to have this debt transferred without any action. And so this is the kind of stuff that keeps me up at night. But I did want to say there's other stuff that can keep me up at night, and that is the hope that humanity can understand this slowing of the climate system down by the oceans, the trap that we're in right now by assuming it's too slow to be a problem, and the incredible opportunity we have to innovate with a whole bunch of technologies that we already have at our disposal. They're low-carbon ways of making energy. Windmills have been around for centuries. This university leads in solar power and solar technologies. There's geothermal, there's power storage that's ramping up. And so this is not something to be scared of, it's something to embrace. So I want to say, let's stay awake at night thinking about this new economy we can grow that's low in carbon or no carbon, and that drives us to a future that gives young generations a much lower cost for our mistakes in the past. Thank you.